Hey, it's Lucky. Sorry for disappearing on you guys, but I've returned bearing gifts. This is my first project in 4.3. It's called Pocket Godot, and it's a small little collection of touch-based controllers for mobile devices, which I think are a great start for building mobile/touch-based games. In this project there are 3 demos included, a first-person demo, a third-person demo, and a top-down demo, taking inspiration from the most popular mobile games like PUBG, Call of Duty Mobile, and games like League of Legends Wild Rift or other top-down RPGs. All these controllers are based on this joystick-touchpad combination, where you have the joystick on the left side and a touchpad on the right side. I think most viable mobile games right now are using this layout, and this joystick-touchpad combination is at the core of all these demos. So we'll run through the code, run through the project, and you can get started on making your own mobile games. All the source code and assets are included in this video down below in the GitHub repository. There's also a build APK, so if you just want to test it on your mobile device, see Godot's performance, it's also included in there. And without further ado, let's get into the project. Alright, so when you download the project from the description and open it in Godot 4.3, very important, use the right Godot version, this is the scene that will open. To start off, I'd like to give a quick overview of the file organization and the scene structures, and then we'll get into the details of the mobile game. So this is a mobile project, so we are on Renderer Mobile. And we're building for Android, and in order to test on desktop you're gonna have to go into project settings, and then in input devices pointing enable touch from mouse. This will make it so when you click in the debug window it will emulate a touch. This way you can test touch-based input with your mouse. The project basically consists of 4 scenes: the main menu scene, the first person demo, the third person demo, and the top-down demo. All my scenes are structured in the same way. There's one spatial node that contains everything, which is called the world. Then every scene is an environment node. This just contains the world environment and the sunlight. And then we have the stage, which is just the world, so the floor, and in the demo cases the walls. And then we have a control node which contains the UI for that scene. Now let's quickly run through the file organization. Here in the file system you can see I've color-coded all the folders. The assets contain the fonts, the icons, the models, and the textures for the project. The resources contain the materials used for the project. And the scenes will contain all the complete scenes, so the main menu, first person demo, third person demo, and top-down demo, but also little sub-scenes. So that touchpad joystick controller that I talked about is its own little sub-scene, and one of the demos uses these little spells for the top-down demo, and there are also little scenes. I've also separated off the world for all the demos, so these little houses in the floor. It's its own little stage which every demo uses, so if you change this, every demo will adapt. And the last scene is the main menu. Then for scripts I did a similar separation. We have for the controls the script that controls the touchpad joystick. For the menu scripts we have the home button that is used in the demos to come back to the main menu, the menu manager, which we'll look at first, and the turntable, which is just this little phone rotating in the main menu. Then for the different players, we have of course for every demo their own little player controller. We'll dive into those also. And these spells, they're just the little rockets and circles that are used in the top-down demo. They're extremely basic. I probably won't even go over them. So let's look at how I manage the menu. If you go right here to the 2D view of the main menu, you will see the UI nodes, which just consists of this little fade background, these little graphics in the top right and bottom left, and then the actual menu. Actual menu is super simple. It's just this title and a bunch of buttons, which I've connected to the menu manager using signals. Signals can be found right here in the top right under node. Any button has a set of signals for button down, button up, and pressed. And if you want to connect a signal to a piece of code, you can just double click them and you can find the script that you want to connect it to, for example the menu, and it'll create this method that is called when the button is pressed. And that's what I've done here for all the buttons, and it's that simple. If you click the FPS demo button, it opens the FPS demo scene. Super simple scene navigation, nothing fancy going on. And for the about menu button and for the back menu, it just hides the button list and shows the about, or hides the about and shows the button. Let me show you. So if you click about, it just shows the text of about, and if you go back, it shows the buttons again. Super simple. If you click any of the scenes, it just loads into that scene. Alright, now let's look at the actual demos. I'll close out the main menu and we'll hop into the first person demo. This is the easiest one. So again, these scenes are structured in a world node, an environment node, holding the world environment in a directional light. This one also has an object node, which will contain the player and possible enemies or pickups. A stage node, which is that border and the floor, and a UI node. So all these demos use this touchpad joystick scene. We'll hop into the scene. As you can see, by default this scene is completely empty. That's because the joystick is hidden by default and you can see the touchpad, and we'll show them once the touch starts. So let's look at this script. This is the core of the whole project. I'll actually maximize this. So what this scene uses is the UI elements for the base of the joystick and the handle of the joystick, a joystick scale. This is based on screen height. So right now it's 33% of the screen height. We're doing it like this because all touchscreen devices have different resolutions, and if we do it based on resolution, it's going to be a huge pain in the butt, and this way it's just easier to scale your UI. Then, because we're using multi-touch input, we're going to keep track of the index of the finger from the joystick and the index of the finger from the touchpad. This is because you can have two touches at the same time, and we're going to keep track of what they are doing so we know if the joystick is moving or the touchpad finger is moving. These are two variables for keeping track of the joystick size based on that scale factor. We'll calculate them later. And this variable is used for keeping track of the change in the touchpad movement. We'll get into that in a moment. Then these are the two variables for actual output. So the joystick is going to the player and the touchpad delta is going to the player in order to move around and look around. And this is just a couple variables for keeping track of the window width and height. So in the ready function, this is the function that runs once the scene gets loaded. We're getting the window height and window width, and then we're setting the joystick size based on the joystick scale, super simple, and then we're scaling those two UI elements to match. Now this is where the script gets a little complicated, but it's important for you to understand this, so if you're going to make your own game based on this controller, you can completely adapt it to your needs, and you actually know what's going on under the hood. We're getting the input function. This function is called on every input, so key inputs, touch inputs, mouse inputs, and we're filtering for event touchscreen, meaning we're going to check if this input is a touch. Then after that, we're going to check if the event is starting or else it's ending. So we'll know, okay, so a touch is starting or a touch is ending. And then we're doing one more check, and that is for the side of the screen. So here we can see we're getting the viewport screen size, and we're checking if this touch is on the left of the screen or the right of the screen, meaning it will be a joystick touch or a touchpad touch. If you would want to create a left-handed version of the script, you just flip this around, meaning that now you're checking on the right side for a joystick and on the left side for a touchpad. But I of course know that left-handed people don't really exist, so we'll keep it as default. And what we're doing once we know, okay, this is a touch, the touch is starting, and the touch is on the left side of the screen. We're going to show our joystick. So we're going to show the base of the joystick and the handle of the joystick. And we're going to move this joystick UI to the position of the touch. So when we start the touch, the joystick is in the center of our thumb. And then we're going to keep track of the index of this touch. This way we can keep track of what the joystick finger is doing. If we're on the other side of the screen, we're just going to start our touchpad location. So we're saying, okay, this is where the touchpad touch started at the event position, and this is the index of the finger that is on the touchpad. Now we're moving into that else from that pressed condition. So this means if a touch is ending, handling the end of a touch, we'll check which touch is ending. Is the joystick touch ending or is the touchpad touch ending? And all we're doing when the joystick touch is ending, we'll hide the joystick, we'll reset the joystick to 0, and we'll clear that finger index, so we no longer have a joystick finger. And for the touchpad, all we have to do is null that finger index, saying we don't have a touchpad finger anymore. Now we'll move into the bulk of the logic of this script. This is on the drag function, meaning that we're capturing an event, and it's a touch event, and it's a drag. So we're moving our finger across the screen. The first thing we're going to do here is check which finger is actually moving. So we're going to check the index of the event against the joystick index, and here we're going to test it against the touchpad index. So now we'll know, okay, the joystick finger is moving or the touchpad finger is moving. In the joystick finger moving logic, we're gonna move that handle. So we're gonna create a variable for the handle position, and we're also gonna create a variable for the handle position normalized. I'll get into this in a moment. Here we're just doing some logic for positioning the UI, because UI elements have their center at the top left. So we're just gonna wanna move it over by half its size, so it's in the center. And then we're gonna do some logic to normalize that handle position. What normalization means is creating a vector that starts at 0 and ends at 1 or -1. This is important because our joystick, the actual output of the script, we don't want it to be based on the screen size. So let me show you what I mean by that. We don't want to output the actual distance the joystick has moved, because this can be over 100 pixels or over 200 pixels, depending on your resolution. We want to normalize that. So we want to say this is 0 and this is 1 to the right, and not the actual screen resolution, so not 300 to the right, for example. So that's what we're doing here. We're dividing by that size, so we get a nice variable between 0 and 1. And this is what we're outputting right here to the joystick variable. We're setting it right here. Now you can see there's a little more logic below setting the joystick. You might be wondering why that is, and that's for actually normalizing the handle position. This is so if your mouse or your touch moves outside the base of the joystick, you can see it clamps to that base, and the handle doesn't just move with the touch all the way off the screen. So it behaves like an actual joystick. We're testing for that condition here. So we're saying if the distance from the event is larger than the base size, so if it's off the base, we're just going to be setting it to that normalized position. So the handle can never move off the base of the joystick. Now for the logic of the touchpad, this is way simpler. All we're doing is we're getting the difference between the last position of the touch and the current position. So here you can see we're creating a movement variable. This keeps track of that difference, and we're setting it equal to the current position of the touch minus the last position of the touch. So here we're capturing the difference between the last time we called this function and now, resulting in the movement of the finger. Then we're adding that movement onto an accumulative variable, a touchpad delta. This contains all the movement that has been done on the touchpad. Now you might be wondering why we're doing this and not just outputting that movement. And that's because here in the get touchpad delta, we're getting that accumulative movement. We're doing this because we might be getting the movement from an update function, which might not run in sync with an input function. It sounds a little bit complicated, but for example, this function can run 10 times before the player gets the movement delta. So you have 10 different movements, and if we would just forget them after every movement, we'll lose a lot of data. But if we accumulate it onto this touchpad delta, and then only when it's requested, we're dumping all that data out and then resetting it to 0. This way, not a single piece of movement is lost on the touchpad. So even if you're not always getting data from the touchpad, no movement is ever lost. That's why it's very important to always use this get function to get the touchpad delta. So that's quite a lot of code, but I think it's important to understand what is going on here, just so you know what we're dealing with. The rest of the code is very simple, but this is just the bulk of the logic, which is important for the touch input. So now that we've got that out of the way, let's look at the actual demos. Alright, let's look at these demos. I'll head into the first person demo, close out of this. And while we're still on UI, let's actually look at the UI of all these demos. They all contain that joystick touchpad that we just talked about, a home button, which is again just a button node, and I'm not connecting a signal here because it has its own logic. So if you quickly look in this script, all it does is when it's pressed, it goes back to the main menu. Couldn't be any simpler. And then in the UI node, we also have the right-sided buttons. This is the jump button, and in the top-down demo, these are little buttons for the spells. And this actually put me off when I was making this project, because it uses touchscreen buttons. These are the only nodes that is included in Godot for touchscreen functionality, and I thought I'd have to use them. But they were a little confusing to me, because if you go to the documentation, they read, touchscreen buttons allow on-screen buttons for touch events intended for gameplay use. Unlike control nodes, you cannot set anchors on them. So what that means is it has no anchor tab. If you look at this button, for example, you can anchor the button to the center of the screen in the top. This is very important because not all mobile devices have the same resolution. And when you anchor something to, for example, the top or the right, it will stay glued to the top or the right no matter the resolution. So let me show you what that means. If your phone is a little bit longer, the home button will stay on top. But if your phone is a little shorter, it will stay at the same position. Now this threw me off because a touch button, how am I going to make a right-sided touch button if I can't anchor it to the right? So in reality, it is kind of like a control node. You can just put it inside another control node. Here I have this control node right-sided buttons, which has its anchor set to the right of the screen. And if you make your touch buttons a child of that control node, they will also stay to the right. So yeah, a little bit confusing in my opinion, because here it says it's a 2D node and not a control node. But yeah, if you want to position them to the right side of your screen, or the left side to your screen for that matter, you can still use them as a control node when making them a child. So yeah, that's just one thing to keep an eye out. Left my head scratching a little bit. I've actually left a comment, I believe. Yeah. So if anybody else runs into this problem, I hope they'll see that comment. Anyway, so these are right-sided buttons. They will stay to the right of the screen no matter what. The joystick touchpad will be a full screen always. And that's all the UI for these demos. So let's look at the code for these demos. All the players use a character body 3D. This is intended use for a player in Godot. And they all use the default player controller template. If you don't know, if you create a character body 3D in Godot and you add a script onto it, it will give you this template, basic movement. And that's what we're basing all these controllers off. But of course they have small alterations to work with the touch controller. First of these alterations is that they require a touchstick joypad. You can see if we, let's remove this. You can see if we click on the player node, it will ask for a joystick touchpad node to be given to it, which is right here. And then we'll also have a look sense variable, which is not in there by default. This is just to have a sensitivity variable for the touchpad for looking around. And we're also adding on a jump just pressed variable. This is just for jumping. Then in order to process that touchpad data, we're creating a look function. All this will do is it will take that vector from the touchpad, so your movement up, down, left and right, and it will rotate the head of the player based on this vector. Super simple. And in order to actually call this look function and make the player look around, in the update function or the process function, we're calling the look function and we're giving it that joystick touchpad variable, and we're getting that touchpad delta. You can see we're using that get function. This is very important, otherwise you will lose some data and it will feel very laggy. And then for the movement, this is super simple. In the default version of this template, here it gets the arrow keys. It just says get access, and we're just replacing that with get joystick. Joystick touchpad, get joystick, and the rest of this code is all the same. Then you can see we've connected that jump button from the UI. So UI jump button node, again a signal for pressed, and that pressed signal is connected here to the player controller, where it will say jump just pressed equals true. And here we're handling the jump. In the default version of this template, it's checking for the space button, and here we're just checking for that variable, aka the touch button, and we'll jump. Super simple, small alteration of the default template, but a very good starting point for any player controller. So let's have a look at that first person demo so you can see it all in action. Here we're creating that touch joystick and we're passing it onto the movement, which is working as intended. And if we're touching on the right side of the screen, you can see we're passing that touchpad delta into the rotation of the head. And the touchscreen button will jump the player. Super simple, nice starting platform for creating a first-person demo. I've kept the graphics all super minimal so you can add your own themes to it, do whatever you like. Alright, let's look at the third-person demo. So the third-person demo uses that same template again for the player controller, only this time it has a little model because you can actually see the player. I just use a bean as is tradition in game dev. And there's one more added bit of logic, and that is this raycast. This is for making sure that the camera never enters any geometry. I'll show you what I mean by that. If I'm moving in front of a box and I move my camera down, you can see the camera doesn't go into the box, but instead nicely moves along the surface. Same for the floor and the walls. This way your player will always stay in view. Let's look at that code. Most of the code is exactly the same as the first person player. Let's go to third person player. As you can see, we're still getting that touchpad. On this time we're also getting that collision ray for the camera. We're still using the speed and jump from the default template. Look sense is exactly the same. All this is exactly the same. Look function is exactly the same for the third person controller. But here, this is the only bit of added logic. So what this does, this is the camera ray, and if it's colliding, we're moving the camera to the position of the collision. Sounds a little complicated. Let me show you. All we're doing is checking if this blue line is hitting anything, a wall, a floor, a box, whatever. And if it is, move the camera to the position of that collision, meaning that the camera will never be inside any geometry. And it's the only different thing about this third-person controller. And of course, we moved the camera to the third-person position instead of the first person. Very simple as well. So for the top-down demo, I had a little bit of fun with it. You can see I've added the extra buttons for the spells. Let me show you what I mean by that. So here we can shoot these little rockets, and we have this little, I don't know what to call it, ripple spell. And we can change color with the other one, and we can still jump. This is just me having a little fun with the project. Looking at the top-down player controller, you can see a lot of stuff is similar. The only difference here is that we no longer have the look function. That's of course because the top-down version has a static camera. We're always looking at one angle. We don't move the camera around in the top-down version. So we have actually no use for the touchpad so far. But a lot of RPGs nowadays use the touchpad for maneuvering the camera around in space. So if you want to see other parts of the map. So that's a function that you can use for the touchpad, or maybe maneuvering spells a certain way. So I did leave the touchpad in here just because it can be used for a lot of functionality. The only thing different here is that we're loading in these spell scenes. I showed you in the beginning, they're these super simple scenes. Spell A is just an object moving in one direction, and spell B is just a circle scaling up. And then you can see down here, I've again connected those touch buttons. Let me actually go out of full screen. I've connected those touch buttons, action A, B, and C, connected them to the player controller. So here we spawn a spell A, spawn a spell B, and the third spell just changes the color of the player. We're not rotating the player in this one, because again, the camera angle is static, so all we're actually doing here is rotating just the model. The player itself stays in one direction, so up is always up, but the model gets rotated to match the movement. So I think this project is a nice starting off point for creating mobile games. You got a lot of examples here. Also feel free to use my menu. So if you wanted to start using this project for your own game, change up the title, add in your logo, remove the demos you don't want from the project and the scene, and then just start coding onto any of the demos that you would like to experiment with. I had a lot of fun making this project. I hope you guys learned something from it. And the last thing with this project I wanted to talk about is exporting, so you can actually use it on your phone. If you want to export for Android, you're gonna have to go through a couple of hoops. It's not as simple as just hitting export. You're actually gonna have to install the Java SDK and the Android SDK using Android Studio. I'll leave a link to a tutorial to set it up. So yeah, that's Pocket Godot, the little starter kit for making mobile games using Godot. I hope you guys get some use out of this. If you do make a game using this, please send it to me. I do showcases on the channel showing off viewer made projects. So yeah, I would love to see your work. If you have any questions, drop them down below in the comments or shoot me an email at lucky.business@gmail.com. I'm always answering questions everywhere, or on the GitHub repository actually. Whatever you like. Yeah, see you guys in the next one.